Hi viewers, this is Sri Ramulu. Today's topic is decay of charge in capacitance resistance circuit or CR circuit. When the condenser is fully charged, the key is released, that is, it is now connected to a point B. So key is released means like this. See the diagram. So when K value is connected like this, then this is circuit will be closed. But so it indicates growth of charge. In decay of charge is like this. When K is connected to B, then this circuit will be closed. In this circuit, no battery, so that is why charging cannot take place. Discharging will takes place. Discharging means decreasing, decay. Now the condenser starts to discharge at a definite rate. Let Q be the charge remain on the condenser plate. Condenser is and capacitor both are same, they are not different. At any time t during the discharge. At this instant, potential difference between the plate is Q by C. So Q by C is simply minus Q by C we outright. Why? Because this charge this voltage which develop across the capacitor, it can make to oppose the decreasing charges. Okay, according to Ohm's law, this should be equal to Ri. So see here I have written minus. Why? Minus means it oppose the decay of charges. Yes. Now what you have to write? Write I value. I is what? Current. Current can be written as charge by time, dq by dt. So in the place of I write dq by dt. Right. Next. And bring R this side and t dt and R bring this side, only Q bring this side. Then equation is like this. Now the equation becomes like this. Now integrate on either side. When you integrate, what you get? So you get like this. Okay, so it is dt by RC can be written as 1 by RC also, minus 1 by RC. So 1 by RC take outside and write it is like this equation. So integration of t, integration of it is actually 1 with respect to t becomes t only. So that is why this t is written and a is kept. Why a is written? When we integrate on either side, then we have to write a constant. That constant is called integration constant. And see this equation q, if you differentiate q, then we write simply dq only. So its differentiation is presenting above. Q differentiation is presenting above. When one quantity differentiation present above, then we write the formula this one, log f of x. So log q is written. Okay, where a is integration constant and it can be calculated by applying initial conditions. What are the initial conditions? At time t is equals to 0, charges cannot start to discharge. So capacitor cannot discharges. But so it is not discharging means it may contains maximum charges. How it got maximum charges? It got the maximum charges when we charge it. So when we charge it, it may gain the maximum charges. Now we are in a position to decrease. We are in a position to discharge, decaying. So before decaying, it may contain the maximum charges. Now apply that for those two formulas in above equation. Then we write it like this, and from this we can get like this. In the place of q, q naught is written, and in the place of t, 0 is substituted. Okay, see above equation. So in the place of q, write q naught. In the place of t, 0. This 0. So a value we got like this. Now substitute a value in above equation, then we can write like this. Bring this to this side, it become minus. So log a minus log b form is there. Then log a by b formula. Okay. Now log A by B. So when it is when the formula is in this form, then we can write it is like this. So write e power this value and make it equal to y. Okay, e power this value and make equal to this value. So q by q naught is equals to e power of this value, and I bring q naught this side, it becomes like this. Okay, so it is not 1 by RC, simply RC only, which one lambda is equals to RC only. It is wrong, only lambda is equals to RC. This lambda is called time constant of RC circuit. Okay friends, so let it is equation 2. Now it is obvious from that the charge in the circuit decays exponentially as shown in figure. So see, figure is showing charge is taken on y axis and time is taken on x axis. So the time before starting it may contain maximum charges, and after starting time it slowly decreases like this. At a time t is equals to RC seconds, the charge in the circuit is given by q is equals to q naught e power of minus t by RC. Substitute t is equals to RC value here, then you can get like this, and it is becomes minus, both two things cancel minus. My e power of minus 1 can be written as like this, e value we know and substitute here. So then we get, by simplifying this value into q naught, 0.37 into q naught. Okay. After t is equals to RC seconds, the charges reduces to 37% of maximum current. It is not current, maximum charge q naught. So time constant is defined as time interval during which charges decays to 37% of maximum charge during decay. It means how much time will take to decrease the 37%, that is called time constant. The rate of decay of charge is given by, so we know the formula, q is equals to q naught e power minus 1 by RC into t. Okay. So to this equation differentiate on either side to this equation, then what you get? You get like this. Now differentiation of it is constant, cannot be differentiable, so its value is 1 minus 1 by RC into e power of minus 1 by RC into t. Why? E power of minus ax differentiation is minus a into e power of minus ax. So same thing is written, it is came down and see here, and it is again exponential term is written as it is. So from equation 2 this is written as q only. So this is the equation. This equation shows that rate of decay of charges. Okay friends, so please don't forget this video till the end. Thank you friends.